Let's talk about mixture problems today. Mixture problems in general tend to be one of the more difficult type of problems for people. So we're going to try and make it a simple idea for you. So a mixture problem is exactly what it sounds like. You're mixing together two different quantities to come up with a solution. It can be anything from chemistry to we're going to use some candy examples, etc., etc. And like I said, we're going to try and make this simple with a real easy visual organizer for you. So let's just kind of jump into it. It says how many kilograms of gourmet candy selling for $5 per kilogram should be mixed with 2 kilograms of $3 candy to obtain a mixture worth $4.50. And so what we're doing is this. You can kind of imagine we're taking a bag of candy over here, okay, and in that bag of candy we have, it's $5 per kilogram, okay, and then over here we got another bag of candy, okay, it should be mixed with 2 kilograms with $3, so this is our $3 candy. And we're going to pour it in to a final solution, okay, and this is going to end up being $4.50. And hopefully this makes sense. This solution down here, this final mixture, the value of it should be somewhere in between here, these two up here. Okay, now, how much of each are we doing? Well, it says how many kilograms of the $5 candy. So we don't really know. So we're just going to call this X. Over here it says it should be mixed with 2 kilograms of $3 candy. So it's 2 kilograms. Will obtain a mixture worth. Now, how much of this is there? Well, hopefully this makes sense. When you pour this amount and this amount into this bag, this amount should be these two added together. So this one's going to be X plus 2. And so in order to come up with the equation, we're just adding these two to equal this one down here. So my equation is going to be 5 times x plus 3 times 2 equals 4.5 times x plus 2. And there's your equation. Let's simplify. This is going to be 5x plus 6 equals 4.5x plus 9. If I subtract my 4.5x, now I'm going to subtract 6, so I'm going to do 2 steps in one. So I'm going to get 0.5x equals 3. If I divide by 0.5, I get x equals 6. If you don't believe me, do it, okay, and give it a shot. I promise 3 divided by a half is 6. Okay, so what does that mean? Well, as I look back at my thing, or at my little diagram here, X right here, that's how much of the $5 candy, and that's what you're being asked. How many kilograms of the gourmet candy selling for $5? So you will need 6 kilograms of $5 candy. Okay, and that's all there is to it. Hopefully this little visual is a good thing for you. Hopefully it kind of gives you a little explanation of how to set things up. Okay, so let's try one more. Okay, it says how many pounds of $4 coffee would be needed to mix with 15 pounds of $2 coffee to attain a mixture of 350. So if we kind of go through the same thing over here. Okay, so we have our 2 bags of coffee here and we have our solution. So how many pounds of $4 coffee? So I don't know how much of this. 15 pounds of $2 coffee. And again, that's going to be dumped into this. And again, it says to obtain a mixture worth 350. And so this amount is going to be these two added together. So it'll be x plus 15. So my equation, 4x plus 15 times 2, you're adding these and it'll equal this, equals 3.5 times x plus 15. Okay, then your next job is to go through and simplify that. So I would just rewrite 4x plus 30 equals 3.5x plus 3.5 times 15, which is 52.5. Let's subtract your 3.5. And I'm going to subtract 30 again. I'm going to do 2 steps in one. So I get 0.5x equals, looks like over here, 22.5. Divide by 0.5, x equals 45. So the question is, how many pounds of $4 coffee? I'm going to squeeze it over here, sorry. So you will need 45 pounds of $4 coffee. And there you go. Okay. So again, I think making that visual is a really good thing for you. Okay, so we're going to talk about a different type of mixture problem. This is more of a chemistry type problem. It says you're going to perform an experiment that will require a 15% solution. Now, one of the things that you need to understand is this terminology of 15% solution. Okay, when you're talking in chemistry problems, and something is described as like a 15% solution, what that means is this. If I just kind of draw a little visual over here. Okay, you kind of have this thing here, and in it, there's a bunch of liquid. Okay. And so when they say that there's a 15% solution, what they're saying is out of this liquid, okay, you have two things. You have water, okay, which is the vast majority of it. You have all this water. And then a small portion of it, okay, this small portion of it, okay, this would be something else. It'd be, you know, just depends on what you're talking about. You're talking about an acid, you're talking about some sort of other sort of solution that you'd mix in there. So when they're talking about, in this case, that you have a 15% solution, it means you have this liquid that most of it is water, but 15% of it is something else. Okay? So when we are talking about this, we're going to mix together, it says, perform an experiment that will require a 15% solution. However, you only have a 10% and a 30%. So in other words, we kind of have this, again, forgive the drawing here. Okay, so you got this mixture here, and then you have this mixture here. Okay, and you're going to dump them into this big mixture here. Okay, so we want this one to be 15%. But this one up here is 10%. And this one over here is 30. So this one's not enough. This one is too much. So we're going to kind of dump them in. Okay, and then as I dump these in, hopefully we dump in enough of each so it'll dilute to be 15%. And again, you notice that this is in between these, just like the ones up there. So let's get some other information. It says you only have a 10% solution and a 30%. How much of each solution do you need to get a 10-liter solution of 15%? So I need this down here to be 10 liters. But I don't know how much of these. So what I'm going to do is this. I'm going to call this x. And if this is x and the total has to be 10, that means this has to be 10 minus x right there. So in other words, it's going to be, if this is x amount, then this amount is going to be the total minus this. Okay, now to write my equation, it's the same thing. I'm going to do 10 times x plus 30 times 10 minus x equals 10 times 15. Okay, so I'm going to simplify. 10x equals, oops, not equals, plus 300 minus 30x equals 150. Simplify some more. Looks like I can combine some like terms. I get negative 20x plus 300 equals 150. I would subtract 300. So I get negative 20x equals negative 150. Divide by negative 20. X equals, looks like this is going to end up being 7.5, I believe. Okay, and what does 7.5 stand for? Well, that stands for how much of the 10%. Okay, it says how much of each solution do you need? Well, if this is 7.5, then this is 10 minus 7.5, so 2.5. So, my answer, you will need 7.5 liters of 10% solution and 2.5 liters of 30% solution. And hopefully that makes sense. You know, we have 10%, which is closer to 15 than 30%, so we're going to need more of it, okay, to get this mixture of 15%. Okay, let's talk about one last type. Okay, we're going to talk about this problem right here. It says how many liters of pure water must be added to 10 liters of 21% cyanide solution to produce a 15% solution. So again, we're dealt with, we have this solution here, we have this solution here, and then we have our final solution. Okay, now over here it says how many liters of pure water. Okay, so if when we are talking about a 15% solution or 20% solution, remember that percentage, okay, stood for how much stuff you had that wasn't water. Okay, so 15% solution means 15% bad stuff, the rest was water. So if I have a solution here that is pure water, that means nothing else besides water. That means this right here is a 0% solution. Okay, there's nothing but water. There's 0% of anything else. Okay, must be added to 10 liters of a 21% solution. Okay, and these will be dumped down here to produce a 15% solution. Okay, so the question then becomes how much of this and how much of this? Well, we don't know. It says how many liters of pure water, so I'm going to call that X. Okay, so remember, if I dump all of this in here and all of this in here, then the total here better be this X plus this 10. So when I do my equation, it will be 0 times X plus 10 times 21 equals X plus 10 times 15. Now the nice thing about this is fairly easy because 0 times X goes away. 10 times 21 is 210. Distribute 15X plus 150. Subtract 150. 60 equals 15x. I would divide by 15. X equals 4. So what does that mean? Well, that 4 is how much of the water. So how many liters of pure water? You will need 4 liters of pure H2O. And there you go. That's how you go about solving solution problems.